Hi class, we're going to do a video now on formal charge. Formal charge is an important concept when we're trying to decide which Lewis structure that we're going to use for a given Lewis structure. Because in some instances we can draw more than one Lewis structure and all of them follow the octet rule. So how do we decide which Lewis structure is the most important? We need to use the idea of formal charge to determine the most favored structure, the most likely one, the most prominent one. Formal charge of any atom in a molecule or an ion is the charge the atom would have if each bonding pair in the Lewis structure were shared evenly between two atoms, or equally. Say evenly or equally. So formal charge is equal to the valence electrons minus the assigned electrons. Now we haven't talked about assigned electrons before, so let's define that. Assigned electrons to the atom are all of the unshared electrons of the atom, or you could say the lone pairs, and half of the shared electrons in the atom in any bond. Whether it's a single bond, double bond, triple bond, doesn't matter. It's going to be half of the shared electrons in a given bond. So again, the assigned electrons are all of the unshared or lone pairs of electrons and half of the shared electrons, which are the electrons in the bonds. So we've got a little equation here. The atom's formal charge is equal to the number of valence electrons minus both the number of non-bonding electrons and half of the bonding electrons. Here's a little shortcut that you might use. The number of valence electrons, the formal charge is equal to the number of valence electrons minus the number of electrons inside the circle around the atom. And what I mean is we're going to draw some circles down here. And when a bond is cut by the circle, the number of electrons inside the circle is like half of those shared between the two atoms. So in our example here, chlorine has 1, 2, 3, 4, 5 electrons. And if we look at oxygen, we've got 1, 2, 3, 4, 5, 6, and then this one would make 7 inside of the circle. Okay, this other oxygen is 1, 2, 3, 4, 5, 6, 7 inside that circle, and then the other one would be 1, 2, 3, 4, 5, 6, 7 inside of this circle. So you can just kind of circle each atom, and the number of electrons is what's inside the circle. Okay, over here, that oxygen would have 1, 2, 3, 4, 5, 6 electrons inside this circle. And then the nitrogen would have, let's see, 1, 2, 3, 4. Oxygen here has 1, 2, 3, 4, 5, 6, 7. And then this oxygen has 1, 2, 3, 4, 5, 6, 7 electrons inside that circle. So it's just a shorter way of finding the formal charge, which I think is a lot easier than this technical definition up here. It's the number of valence electrons that each of these has based on looking at the periodic table, looking at what group it's in, and then you subtract the number of electrons inside the circle. So if I was looking at chlorine in this first example, chlorine is in group 17 on the periodic table. So that means it's got 7 valence electrons. And I'm going to subtract the number inside the circle, which was 1, 2, 3, 4, 5. 7 minus 5. And this is assigned electrons. Okay, 7 minus 5 gives us a formal charge of 2. So this is our formal charge. And then if I'm looking at oxygen, it would be group 16, so we have 6 valence electrons minus 1, 2, 3, 4, 5, 6, 7, so minus 7 valence electrons, and since all of them have the same number, we just do that once. So for each of them, we're going to have a -1 formal charge. Looking at NO3, and by the way, this is an important skill. You're going to find out what we use it for in a moment, but you want to make sure that you know how to find formal charge. Let's do nitrogen, and then we have oxygen in the double bond, and then we have oxygen with a single bond. You got a couple different things. Nitrogen has, again, well, it's in the 15th group, group 15, so it'd be 5 valence electrons, minus 1, 2, 3, 4, minus 4 assigned electrons, gives us a formal charge of +1. By the way, it's a good idea to label whether it's positive or negative. Okay, oxygen in the double bond has 6, well, they both have 6 valence electrons because oxygen's in group 16. And the one in the double bond has 1, 2, 3, 4, 5, 6 assigned electrons. 6 minus 6 gives us 0, formal charge of 0. And the other oxygen, the one with a single bond, is 1, 2, 3, 4, 5, 6, 7. 6 minus 7 gives us -1. All right, and then finally, C2 minus. C2, 2 minus. It's got this triple bond. Looking at the circle, I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, let's decide what our formal charge is. Well, carbon has 4 valence electrons since it's in group 14, minus, we just said there's 5 assigned electrons, 1, 2, 3, 4, 5. So it's got a formal charge of -1. That's how you find formal charge. The application of formal charge is that if you have more than one Lewis structure possible, we can use formal charges to predict the dominant structure. And the dominant Lewis structure is generally the one in which the atoms all have formal charges closest to 0. So whether it's a positive number or a negative number, you want the one that's closest to 0. If 0 is possible, that is the dominant structure. Also, we need to keep in mind that the negative formal charge is to be put on the more electronegative. It's a lot to fit on that line, but the more electronegative atom in the Lewis structure. And remember, when we're thinking of electronegativity, that's our snow cone trend. And remember that last column, the noble gases do not count, okay? But it's the snowman trend for all of the other parts of the periodic table, excluding the noble gases. So let's look at our formal charges in this and decide which Lewis structure of the sulfate ion is the most dominant structure. So first we have to find our formal charges. Let's circle each atom. Got this one, this one, this one, and this one. So all of the oxygens are single bonds. And it looks like they've got 1, 2, 3, 4, 5, 6, 7. So each of the oxygens has 7 assigned electrons. Sulfur has 6 valence electrons because it's in group 16. Oxygen has 6 valence electrons because it's in group 16. Sulfur has 4 assigned electrons, so 6 minus 4 gives us +2. In the case of oxygen, we have 1, 2, 3, 4, 5, 6, 7 assigned electrons in every case. 6 minus 7 is -1. Okay, so these are our formal charges. +2 and -1. Now if we look at the other version, it's another Lewis structure of the same the same substance, the same ion, which is the sulfate ion. Circle each atom. And we've got to count up our assigned electrons. All right. So we have sulfur. We have oxygen with a single bond. And we also have oxygen with a double bond. The sulfur has 1, 2, 3, 4, 5, 6 assigned electrons. Keep in mind that because it's in group 16, again, we have 6 valence electrons. Same for oxygen. All right, for the single bond, oxygen has 1, 2, 3, 4, 5, 6, 7. So 6 minus 7. And for the double bond, oxygen has 1, 2, 3, 4, 5, 6. 6 minus 6. So we have 6 minus 6 is 0. 6 minus 7 is -1. And 6 minus 6 is 0. Well, you can see by looking at these numbers that over here we have a non-zero formal charge, +2 and -1. And over here, mostly it's 0 and we have only the -1. So this structure is the most dominant. And it's the most dominant because the formal charges are closest to 0. All right. That's one example. I'm going to pause the video here and then we'll go through a few more.